In this screencast, we'll quantify the effect of adding solute on a boiling point. Or to put it in layman's terms, if you add a little bit of, say, salt to water, how much will it make the boiling point go up? It's a potential urban myth that you can make your spaghetti boil faster by adding salt to it because it dramatically increases the boiling point of the solution. Let's take a look if that's true and understand this effect. So we're going to see how adding solute affects the boiling point of a solution in general. We'll quantify that effect and take a look at the formula that's involved. It has a few pieces to it, and we'll see if it's a big effect or a little effect. This is screencast 11.11. Solutes elevate the boiling point. They make it go up. How come? One argument could be that there's fewer solvent molecules on the surface and they interfere with that boiling process. There's lots of other potential explanations. Those solute molecules absorb energy. Those solute molecules may have a higher boiling point than water, etc. Various things go into, various explanations are possible. And here's what it consists of. This is a funky looking formula, so we got to evaluate each part. I'll say it out loud. Delta T sub B equals K sub B times M times PM. But let's think about what each one means. In many cases, there's multiple letters or symbols for each single term. For example, delta T sub B literally means the change in the boiling temperature. So it's just one thing, how much the boiling point goes up. Note that it's not the boiling point itself, it's how much it gets increased by adding that solute. K sub B is a weird one. That's a constant that you look up. See this list here? A bunch of boiling point constants. Boiling point constants based on the solvent. M, little m, is the molality. Not the molarity, but the molality. That's little m. And it's defined as, hang on, the moles of solute per kilogram of solvent. Let's go back and understand what these other things are. PM, this is the last thing, and it will make sense when you think about it. It's called the particle molality. This is the weirdest part of it, but, you know, thinking about it, it makes a lot of sense. And it's the number of ions that your thing breaks up to. If you have a salt, they always ionize in solution, means they'll break up into their cations and their anions. And if it breaks up into a lot of pieces per molecule, you're going to get a bigger effect. Sugar, well, it's not even an electrolyte. It has no cation, it has no anion, so its particle molality is 1. Sodium chloride breaks up into Na plus and Cl minus. Particle molality is 2. Twice the effect. Notice that it gets multiplied, so it would be twice the effect. Calcium chloride's 3. If you wrote things like aluminum oxide, it would be 5. So, it's an important part of it. There's the molality again. And let's go ahead and solve a quick problem. What's the boiling point of a 2.75 molal aqueous sodium chloride solution? Well, this should give us an idea of that salt water problem with spaghetti that we referred to before. This sounds like much more salt than you'd add to your spaghetti boiling on the stove, but let's go ahead and check it out. The boiling point. Let's write down the formula and plug in each thing. Let's see. There's our molality right there. The particle molality, well, sodium chloride will break into two things. K sub B, do we have it? No, because it's not, well, yes we do. It says aqueous. Here we go. It's based on water, so K sub B, so 0.512. Direct plug-in. There it is. 0.512 is the boiling point constant for water. Notice it is much smaller than the other substances here. That's interesting. 2.75 is the molality it's given. 2 is how many things it breaks up into. It's 2.82 degrees, but that's not your answer. A lot of people think it is. If it asks for boiling point elevation, it would be, but it asks for boiling point itself, so we tack it on to its normal boiling point of 100 since it is boiling point elevation, and we get an answer of 102.82 degrees Celsius. This is screencast 11.11.